All right, welcome back everybody. Today we will start 2.3 and we are going to be looking at two big ideas. We're going to be looking at, and I'm just going to write one big idea here, we'll split it up. Polynomial division. Polynomial division. Okay, right off the bat, there is not a super duper nice way to jump right in. We could give some definitions and stuff, and that would work completely fine. Well. All right, welcome in, Red. Just trying to be obnoxious. Okay. Red, do you know how to divide? Yes. Okay, then you're in luck. We're divided. Okay, right off the bat, without saying anything else, we're going to jump in to everybody's favorite topic, long division. There's a reason I made us just long divide some numbers. It's because we're about to do the exact same thing with polynomials. Do you guys remember long dividing polynomials last year? Like you don't remember how to do it, or you don't remember doing it at all? Okay, so here we go. We jump right in. I heard the word synthetic. We are not using that today. Do not use synthetic. There's a reason that, we will most of the time if you remember it. But there's times when we won't because it's ugly. So we need to make sure we can do this. We're going to just right away do a couple together. So example, that's just long division. Here's our first one. If you want to hold off a second to write it because there's a better way to write this, you make that determination. Just let me write it first. I want us to think about the following. If I were to take 2x cubed minus 5x squared plus x minus 8 divided by x minus 3. Is this the way that we're going to write it when we do the division? No. Can we write it as a long division problem? Yes. Pause. We're going to clean this up again. When we do a division problem, what is the answer called? The quotient. If you've ever seen, I don't have it up on the board. Have you guys ever seen this? You've all seen real numbers. Do you know the integers? Do you remember what this one is? Nope. Okay. How about this one? That's a Q. Not a circle with an H, it's a Q. This circle with the Q right here. We're not going to write it right now. We'll write it in the coming days. This means the rational numbers. Numbers that can be written as a ratio, A over B. And people never get why it's a Q until we think about it here. When you do A over B, do you agree that's A divided by B? And the answer, when you do division, is called a what? It's a Q. It's a quotient. It's a rational or ratio. You're doing division. Okay. So here we go. Just had my stylus. Okay. The thing that we get, the answer is going to be our quotient. What do you call the thing that's being divided? The dividend. And what do you call the thing that we're trying to divide by? The divisor. Okay. We will refine that. I'm sorry?
What's the line in between?
This is a vinculum.
You made him say vinculum.
Did you know it?
Huh?
Did you know it?
I remember Miss Osmond giving us some kind of story about a dude standing on top of a table and saying this. I swear.
Okay. You guys probably have seen. I don't remember that story. I'm sorry.
She just told us that.
Do you know why this is used for division?
Yeah, no.
It's a fraction with a dot over a dot.
I didn't know that.
Yes. Yep. That's why we use this symbol. It's a fraction. Okay. However, let's do this long division together. And we can annotate a bunch, but I think more than just annotating and saying this is exactly what we do every time. There's only a few things that we'll actually say that for. We just need to get a little practice. So I'm going to put my dividend first. 2x cubed minus 5x squared plus x minus 8. And we are going to put our divisor on the outside. All right. Now, we're going to see just how good a memories you guys have. And just so that you know, my memory is not crazy good. When I say I remember teaching you guys something, some of the times I do remember actually interacting with you guys. But realistically, it's because I remember teaching geometry at least once. And it doesn't matter what year, because we teach the same stuff. And there's a few things that I really like to use in common. Do you guys ever remember talking about 30, 60, 90 right triangles with me?
Yes.
Okay, so not our main focus. You don't have to draw this, but there's a 30, 60, 90. Who's the queen? The king, the most important side. Not the hypotenuse. The short leg. This was the most important side of it. I refer to it as a queen, right? Okay, now, if you guys didn't like the unit circle, but you remember this, you're wrong. You should like the unit circle. Maybe you didn't notice the connection between those ideas. When we do the unit circle is super easy. You say that, but it's easy. Okay, check it out. I'm going to use a similar language. This is our queen. This is the most important part of this entire problem right now. All I want to think about is just the x to start. Now, when we do long division, and I'm going to put another one up here. I'm going to just do a long division. You don't need it. I just want to be able to reference this. 227 divided by 4. I look and I go, okay, does 4 go into 2? No. Does 4 go into 20? Yes. I put a 5 here. I multiply them. I put a 20, and I subtract. Now, in essence, it looks a little bit different with numbers, but do you agree that the goal is to get this to subtract out so that that first term falls out? Like, I want that to be a 0 right here when I subtract down, and we'll work our way till we're done. We want that to fall out. Okay, who's the queen on our divisor? And eventually, I want whatever I write right here, it better be a 2x cubed, because in the same way, I want it to fall out. Everybody okay with that? If you're not, we're going to do this a bunch. But here's the first big question. Using this and only thinking about this, is there any number that I could take this and multiply it by that I could write 2x cubed right here? Dolan claims 2x squared. Is it true that if I did x times 2x squared, I would get a 2x cubed? Or if you'd rather thinking about it, because I heard somebody say this, if you took 2x cubed, and this is just the opposite logic, but if I took 2x cubed and divided it by x, I would get a 2x squared also. Somebody, I think it was Lay, that talked about I would divide it, and I don't typically use that language, but if you do, that's cool. Okay, I'm going to first, I like the way Dolan thought about it, or at least said it, I'm going to write a 2x squared. I'm not going to write it here because this is above the cubic. I'm going to write it here. 2x squared. And I know that I'm going to use this because I'm choosing very specifically. Whatever I write here, it's multiplied by the queen to get this number right here. I want to rewrite this so that when I subtract, it's gone. Okay, so now we're going to say the queen is still here. We'll talk to her again in a minute. But what do we do here? How did I get a 20? You're right, louder. Maybe not. How did I know to write a 20 here? I didn't just guess a 20. I multiplied. This thing is just an uglier divisor, but can I multiply? But we have to distribute. Because it's x times this and minus 3 times this. Okay, so help me multiply this real quick. X times 2x squared gets me a what? 2x cubed. And then now I'll do the, and I wouldn't encourage you to draw these every time because it's going to get really ugly. But what's negative 3 times 2x squared? All right. Here is where maybe we have some differences, and it's okay if we have some differences. I did some weird stuff here that I don't really do with numbers, but I stressed it. What's weird about the way I wrote this one? Why do you think I'm really stressing the importance of putting those parentheses here? You have to distribute. Now, if you want to distribute in your problem, you can, but it's really ugly to do this and then say, oh, it's actually negative and a plus. It's awful. Yes, miss?
Where did the 6x? Yeah.
X times 2x squared is 2x cubed, right?
Oh.
What's negative 3 times 2x squared?
Oh.
So it's just like here, we just had 4 times 5. We just have a bigger piece. I never write any more than this. I'm going to just combine straight down. And I don't, like, this helps me avoid doing it. If you would rather do minus and plus and not use parentheses, you can. But I want you to know it's going to look exactly the same every single time I do it. And I always do it like this. I don't want to muddle it up and make it gross and avoid the mistakes if possible. So now we're just going to look at it. 2x cubed minus 2x cubed. 0. I'm not going to write anything, but it's a 0. My next term is negative 5x squared minus a negative 6x squared. What really just happened? So it turns into an add, right? Negative 5x squared plus 6x squared. What do we get? X squared. Like it's hot. We're going to drop it straight down. Straight down. Just like we do here. We subtract and we drop. Everybody see the analogy going on? Okay, we're back to the queen. The next thing that I want to write so that it falls out, what should I want to have right here? I need an x squared. So I'm going to go to my queen. I'll say, what do I multiply u by to get an x squared? It's an x. Okay, notice I haven't looked at the 3 at all. I'm only focusing on the queen. Whatever the 3 brings along to the party, that's fine. But the queen is who decides. Okay, so I'm going to get rid of these signs here because I don't like them right now. I'm going to get rid of that. Now let's do the same thing. I'm going to distribute the queen and the 3. What's x times x? X squared and negative 3 times x. I'm going to put parentheses around it. And what goes right beside these? A negative. And we're just going to repeat. As long as our x squared term, whatever we write first, goes above its appropriate spot, we'll know when we're done because we'll write our last number above the last number. Okay, so help me do this subtraction. X squared minus x squared. They're gone. X minus negative 3x. 4x. And how should I drop the 8? Like it's hot, indeed.
Is the queen always x or is it the first?
It's whatever this first thing is. So if we're dividing by something x minus or x plus, it's always x. If this had been a 2x, the queen would have been 2x. Okay, good question. Okay, I have a question for the queen as well. And not really a question, but now what's the next thought? X, my queen, times what to get a 4x? It's a positive 4, right? I will now put my plus 4 to ensure that I get a 4x here. I'll now distribute all the same. I'm going to get rid of this distribution line. I actually kind of want to get rid of that too. I'll just replace it. Okay, we'll do the same thing. X times 4?
4.
Negative 3 times 4? And parentheses so I don't forget to distribute. And here we go. They're gone. What's negative 8 minus negative 12? 4. Okay. Huge implications coming down the pipe in just a moment. And we may not fully grasp them today, but some really, really important stuff. The hardest part of algebra, I think, is the part that I like the most. It's factoring. Factoring can be hard. Addison seems to agree with me based on her facial expression. She finds factoring hard sometimes. Me too. Okay. How did we decide on the first one that we did if a number was a factor of the bigger one? Its remainder was what? So I heard two different answers. 0. If there's no remainder, it was a factor. Do you notice that we don't have any more space to write because we started with x squared and now we're above the last term? Did we have a 0 left over? Okay, huge implications here. We will refine this. But the fact that when I took this ugly thing and divided by this, I didn't get a remainder of 0. Do you think that tells me anything about this? X minus 3 is not a factor of this. I'm not going to write it right now, but it's not a factor. That's important. I can tell it's not a factor because it's a remainder of 4. Now, if we wanted to go one step further, we do have a way, and we'll refine this over the next few days, or in the next few minutes rather. When we had a remainder, I just took the remainder divided by whatever the divisor was. So like on this one, there will be a remainder, and I'll just check. Help me out. How many times does 4 go into 27? 6. So 24, and then I subtract it. Notice I don't really use parentheses. I get a 3, and that's my remainder, right? So when we write this, you guys may think that we're in a kitchen and you can write 56 3/4, but we're not in a kitchen right now. We're not baking. We're not measuring. That's really just a joke. But do you guys agree that that's the same thing as this? This feels unnatural with numbers. We're going to do this, though. So let's just see what we have. My actual quotient, which I'm okay to call just a dot right now, and with an equal sign, we don't have the letters yet. I think that when we took this cubic and divided by this, we wound up with a quotient of 2x squared plus x plus 4. And I had 4 left over out of what was I trying to divide by? X minus 3. We have a remainder. It was not a factor. Whoever said it wasn't a factor, that's like the most important question I've asked today, and you killed it. Kudos to you. I wish I remembered. Wisha or Addison? I don't remember. Realistically, I'm proud of all of you. Okay, let's do another one. Together, or do you want to try one on your own?
On your own.
Okay, when I say on your own, do I mean it has to be complete silence in here? No, it really just means I'm not going to be doing it at the board. Are there very many times, and give me the real answer, not just a Holloway wants answer, are there many times that it just feels like me just talking rather than there are? I think there are sometimes in here. If it ever just seems like, hey guys, watch me do this problem, don't ask questions, just watch me do it. If it ever feels like that, please call me out. I never want it to feel like I'm just talking at you. I try to make it a discussion, but with harder stuff, it's challenging sometimes because I don't want to call on 12 people to give me the wrong answer. Call me out on it. I want to make it more of a discussion always. Okay, that was Nate. On Bravo, you guys, with your neighbor's help or my help, I'm just going to write it as a long division right off the bat. Our divisor is x minus 2. And our dividend is a lovely cubic again. It is 6x cubed minus 19x squared plus 16x minus 4. I'm going to give you a head start. I'm going to get some steps in. I might do a pretty sweet wheelie on that cart over there real quick. But we'll meet back up. I will be around. Ask questions if you have them. Get help. If you're wrong, it's okay, as long as we correct it. Sweet. What's the remainder?
0.
Meaning what? There's no remainder. When you say it's a factor, what's a factor? X minus 2 is a factor, right? Here's the bigger part. You do not have to write this yet, but this is where we're heading, and I think that we're at a point where we can see it. Can you tell me another, factor? Right now, I have this thing, 6x cubed minus 19x squared plus 16x minus 4. And if right here, right now, I said, factor this. It's not a trinomial, so now you can't use your A times C stuff. You might try grouping, maybe, depending on how much you remember it, but you're not going to group it. Does anybody feel like you could factor this right now? But check it out. If I gave you a little push, instead of saying, oh yeah, well do exactly this. Instead I said, well maybe x minus 3 or x minus 2 works. Is x minus 2 a factor? Yes. And check this out. Huge, huge important idea coming up. X minus 2 was one of the factors. What's the thing that we have to multiply it by to get my bigger expression? Or in other words, can you tell me the other factor that we just found? So if somehow you had a way to know that you should try this as a factor, and we'll learn how we pick what to try, but if we could find that x minus 2 is a factor, here's the other one, right? Mm-hmm. Could this factor further now? Yes. And now all of a sudden we took this big cubic thing and we can factor it down into all the linear pieces. There is a benefit here. I don't know how to factor this if we don't do this. Grouping is what I would try. There is a 4th degree equation just like the quadratic. I've never seen it. I'm sure it's multiple pages of writing just to do the equation. This is handy. This works. Okay. One more, or are we feeling okay with it? Okay. What's an algorithm? You guys have probably heard the word at some point. A system. When I think of algorithm, I think of computer science. But maybe not, because it's just a set of steps. So, did you guys all learn to divide like this when you did long division as children? Yes. I don't know how kids today learn it. I'm kind of scared for Zeke to start learning it because I have no idea how it's taught in elementary school. Not a clue, to be honest. I didn't really understand what was happening here, and I don't know that I still truly understand what's happening, but I know how to do it. Okay. Yep, I'm sure there's other ways to do it. Okay, what we are going to start looking at, we're just going to barely get started on it today. I am not going to give you homework over the weekend. But it means that I want to see you guys all at Kelty Field tomorrow afternoon cheering for the Raiders as they run for regions. Yes. Okay, we're going to sneak something in real quick, and here we go. Our next main focus, we've done some long division. If you remember synthetic division ever, it'll show back up. It's coming, but there's a reason we do this. We are looking at the division algorithm. And if you wanted this to not be an ugly word that you're going to see in computer science all over the place, you could say this is the division set of steps to solve a division problem. I like algorithm more. Okay. Here we go. And I think we'll probably get it. Do you want math writing or wordy writing? You guys really like the math writing?
Yeah.
Like all this?
I like the words. Words, please.
Yep, I'm okay with words. I was not expecting the mathy writing. If you want to change it, you can. For all, maybe. For all polynomials. And I'm just going to use polys. For all polynomials, or polys, and we'll say that they take the form f of x and d of x, such that, and I will use st, that's the one shorthand that I will like always use. For all polynomials f and d, such that the degree, have we talked about degree in here? Okay, if I write it like this, the degree of d of x, is it clear that we're talking about the degree of the function d of x? Okay. For all where the degree of d is less than or equal to the degree of f of x, and additionally, we just need to require that that division, or d of x, sorry, is not 0, because we can't divide by 0. For all polynomials f and d where this is true about their degrees, then there exists unique polynomials that we'll call q of x and r of x, such that, and here's something that I very seldomly do, you guys have to hang from this cliff for the next 72 hours.